Hi, Dr. Mamari again with one more experiment, that is experiment 8, or thermodynamic. What we are going to do today, we are going to find solubility and calculate the solubility product constant, which is the KSP for calcium hydroxide at two different temperatures. But the title of the experiment is thermodynamic. How does thermodynamic is related to the solubility? So we are performing the solubility at different temperature. By titration, we determine the solubility or KSP value at two different temperatures, and we use those numbers in order to calculate delta H, because the ratio of solubility at two different temperatures is directly related to delta H of that reaction. So if we have the solubility or KSP value at two different temperatures, we can measure or calculate the value for delta H. The purpose of the experiment, one more time, for you to have the data value so you can fill the data and do the calculation. When you are doing calculation, you have to refer to your lab manual, which you are purchasing online, the ebook, and during the pandemic and later on you have hard copy, so you will use the lab manual in order to do the calculation and follow the instructions. But I will provide you with the data values that you need in order to start your calculation following the theory. The theory for the experiment is explained on the first few pages of the experiment 8. So when we say thermodynamic, experiment that we are trying to do is a very comprehensive experiment, actually, a very nice experiment, because we can calculate delta G, delta H, and delta S for a single reaction for calcium hydroxide. But in order to find these values, first we are going to do titration, and based on the titration at two different temperatures, we are going to look for concentration of the hydroxide ion. If you have concentration of hydroxide ion for dissociation of calcium hydroxide, then you can find from that concentration for calcium ion, because we know calcium and hydroxide, they are related. One calcium hydroxide, it gives you one calcium and two hydroxide ion. So we have the formula for KSP. So we can, if we have concentration for hydroxide, half of that would be concentration for calcium ion, and we can find the KSP. The key is to find the KSP at two different temperatures. So KSP1 is at the T1 temperature, KSP2 is at T2 temperature. Using the equation, we can find the value for delta H. When we have the value for delta H, then we use the second formula given here for delta G equation. So we have the delta G equation that we can use the KSP, because delta G also is directly related with the value of KSP. The higher the solubility, basically what it says, the higher the solubility for the compound is, more spontaneous the reaction is going to take place. So if you see this negative sign here, it doesn't mean less than 0. It just means that the sign for delta G is negative. That means the reaction is a spontaneous reaction. And also makes sense to say the higher the value for KSP, that means the solubility ion product is high. That means the compound is more soluble. And if it's more soluble, then you are going to get higher value for delta G. That means it's more spontaneous. If it has negative sign and high value, it means it's more spontaneous. So it's directly related to the KSP value. So we have the delta G there. So we have delta H from the first formula, delta G for calculation from this second formula, and the third formula is the delta H relationship between delta H and delta S with respect to delta G. For any given reaction, delta G equals delta H minus T delta S. So you take any of this equation when you did the calculation for delta H and delta G, you can find the value for delta S. So when you have those three, then thermodynamic values, then your thermodynamic for your reaction is solved. So you have the value. I'm going to follow the procedure, and as usual, I'm using my lab manual, so I'm going to stop sharing the document with you, and I will share the camera for you to see to watch me performing the experiment. Record your data as we are moving. So by this time, you know, when I say initial reading, that means that before I add any solution to my flask is the level of the standard in the burette. And if you have already you looked at the data sheet, you know what items you need to actually record, which is a good idea to have the idea of what needs to be recorded before you watch the video. And make sure you read the experiment and answer the questions and the pre-lab assignments before you even watch the video. Okay, experiment. The procedure for the experiment. A solution of calcium hydroxide, if we have it, is going to be filtered into a clean beaker. Then we are going to titrate that. We are going to find the concentration of the hydroxide ion for that solution. At the room temperature. So we're going to first do titration at room temperature. So I'm going to get the calcium hydroxide. First is saturated calcium hydroxide solution at room temperature. Saturated solution from the fume hood. Bring it here. I have set up the gravity filtration. I'm going to add the filter paper to it by folding the filter paper in half, and one more time in half, separate the parts, make paper funnel basically, and then I'm going to get my saturated solution from it. Okay, I need to filter about 40 milliliters to be filtered because I need to use it for the experiment. I may not use all 40 milliliters. The height, it was too high, so it was a chance for splashing, which it did splash if you saw it. I'm letting it to and need to prepare my burette. The solution that goes into burette this time is hydrochloric acid. My hydrochloric acid is already standardized. The burette, what I'm draining or dispensing from the burette is the washing solution that I used. I had it inside the burette since we talked about washing burette before any titration for last experiment. I just went ahead and washed it before I started the experiment today, and I had the solution in there. So I removed the washing solution first. So just based on the habit that I have, I did fill up the burette to all the way to the top. I'm going to bring it down to 4. So I'm at 4. Meniscus is at 4. Now I can, my burette is red. Next step of the procedure, you need to take 10 milliliters of the filtered solution, a different type of pipette, but still is volumetric pipette. So if I fill up the pipette up to this index line, to the 0 line, means that I have 10 milliliter solution in this because it says 10 milliliter. So I need 10 milliliter. I'm going to get 10 milliliter of the filtered solution. And I place that in Erlenmeyer flask. That's the waste container. So I'm going to label it. I don't want to confuse myself. Okay. When you're doing titration, all the beakers, because the solutions, they have same color, beakers must be labeled. My HCl is already labeled, waste container, and this is the calcium hydroxide that I'm using. So if it doesn't have a label, it's not valid. You shouldn't have it at your station. Okay. We are using Bromotimo blue. Bromotimo blue for the titration. Bromotimo blue has a blue color in basic solution and yellow color in acidic solution. So I'm supposed to add enough HCl until the blue color changes to yellow color. So let me just look at the procedure to make sure that we are all in the right page, the right step. Okay, so just need to add 25 ml of distilled water. Okay, 25 milliliters of distilled water. I have the Bromotimo blue. I'm going to add HCl. In the burette, I have HCl set at 4.00. And I'm going to add by stirring. Until the color changes to yellow color. So try to look at it, try to see what I'm doing here. It's easier for me to stir it with the right hand, so I can't go like this, it's harder. I sometimes do it for you to see it, but I could see from the camera that you actually can see the flask and the color. I don't know how much solution I need to add from the HCl, so I better add slowly. I'm glad I added slowly. A yellow color. So it went from 4 to 14. Let me write the numbers for you. L1, I'm sorry. The 10 milliliter, yes, it went from 4 to 14, so it was coincidentally it was the same, because I took 10 milliliter of calcium hydroxide and I used 10 milliliter, so it was a little. And concentration, HCl concentration equals 0.005 capital M. The rest is for you to do the calculation. So this is at room temperature. I will have to do a trial 2. For titration, you can never do one trial at room temperature. So for the second trial, they left me enough flask. Okay. Going to take 10 milliliters more of the calcium hydroxide. We are always looking ahead of the time to the procedure to make sure that, you know, I don't get surprised. Like I need to, for part B, I need to boil 100 milliliters of water, so I can let it stay on the hot plate and boil while I'm doing this part of the experiment. Okay, so going to set this again. It's at 14 now, adding the Bromotimo group, 3 drops of Bromotimo group, 25 milliliters of. When is the trial 1 and 2, everything has to be the same. 25 milliliters of water. Then I start adding. Last time it used about 10 milliliter. It's expected to use 10 milliliter. So I can add the first 5 or 6 milliliter fast. Then I have to slow down because I'm repeating the same experiment. Getting very close. Okay. Yellow color. You see, the color change happened with addition of one last drop. I mean, I add, and then when it gets close to, how do I know it gets close to? Because the yellow color was staying for longer time. So if it stays for longer time, that means it's getting close to equivalence point. So I slow down the addition. Every time I add one drop, I mix it, and as soon as it turns yellow color, I wait for 20 seconds. And if the new color is stable for 20 seconds, that means the titration is complete, so I should not continue. So for second trial, for trial 2, volume of the HCl and the concentration for HCl was the same. And sorry, concentration and the volume is the same for trial 2. So volume for calcium hydroxide was also 10 milliliter, but since is in the procedure, and I did not change the procedure, I'm just going to leave it the way it is. I don't have to record it here for you. It is on the procedure, and you record it from the procedure for your calculation. You use it from the. Since the two trial of the titration is within the agreement, they were exact the same. I don't have to do the third trial of the titration. So I'm moving to part B of the experiment. Trial 1 at higher temperature. Higher temperature. Okay. For trial 1 at higher temperature, I have to get my sample ready for high temperature. 2 grams of calcium hydroxide we are going to add to the hot water and let it boil for 2 minutes. So for 5 minutes, sorry, 5 minutes. So I'm going to measure first 2 grams of calcium hydroxide. Have the 2 grams. I'm adding to the hot water and let it boil for 5 minutes. Let me show you, bring the camera close. Okay. Adding to the hot water and let it boil for about 5 minutes while stirring it occasionally. While we are waiting for the 5 minutes, I need to refill the HCl. Make sure my burette is ready. HCl. Adjust the level, bring it to 10. I could use 0 or 10, but 10 is easier. I don't have to go on my tippy toes too often to see the level of the liquid in the burette. So my burette is ready. I have my flask that I have to use. I'm going to wash these, rinse them, use a new filter paper. I might be able to use the same filter paper, but it's better to come up or start with a new filter paper since I have the time. Start with a new filter paper. We're using 10 milliliters of that filtered sample. Stay for the 5 minutes. It hasn't been 5 minutes yet. It's been 3 minutes. I'm keeping the time from the track of time on the computer. So I have the sample for 3 minutes. I continue with 2 more minutes of heating up. Then I would have to filter it. See if I can manage like filtration here. Because after I filter it, I have to keep the calcium chloride warm. You might be surprised the concentration of hydroxide ion is going down at the higher temperature, but not every. General rule for solubility is that at the higher temperature you get more solubility or greater solubility. Calcium hydroxide is one of the exceptions. So when you increase the temperature, the solubility goes down. If the solubility goes down, the value for hydroxide concentration or concentration of hydroxide ion is going to go down. That means it requires less acid for it to neutralize it. So if you see less acid, it means the concentration of the hydroxide is low. That means the solubility is low at higher temperature. If you use more than 10 milliliters, that means concentration of hydroxide ion is now greater, and means that the solubility goes up by higher temperature, or increasing temperature would increase the solubility. Okay, it's been almost 5 minutes. I'm just going to filter some of it, not everything, because I don't want it cool down, because if it does cool down, then it goes back to like solubility at lower temperature. So I would only filter about 10 milliliters that I need to use for my first trial of the experiment, and then I will start the titration right away. And I'm going to take the temperature of the filtrate, so I know what temperature I have to record for you. And I also should record the temperature for the room temperature, so you have a numerical value. The room temperature records at 22 with this thermometer. Since I'm using the same thermometer for the high temperature, so it's better to record that as the temperature of the room. So T1 is 22 degrees Celsius. Turn it off. Measure 10 milliliters of hot solution. Give it the temperature because you need the value for temperature. Leave it there for phenolphthalein, not the phenolphthalein, the indicator, which is the bromotimo. 25 milliliters of water. Starting from 10, and I'm going to add the HCl. I don't know how much it's going to use, so I'm just going to add slowly. Okay. The volume for acid is 6.00 milliliter. Concentration for the acid is that was for the first trial. So I'm going to perform the experiment for second trial. New flask. I have to filter again. Filter. Discard this. I don't want to use it. Since it's my last trial, I'm filtering more. I just want to make sure I have enough for the thermometer bulb to sit in there to give me the temperature. Okay. Okay, 10 milliliters of calcium hydroxide at high temperature. Get into a new flask. Add 3 drops of the indicator, Bromotimo blue, 25 milliliters of ionized water. Going to set this at 20. Okay. Last time I used about 6 milliliters or 6 milliliters. I have it recorded. I'm going to start the second trial, adding the HCl until the color changes to yellow color. From blue color, it should change to yellow color. .5. As the numbers are not exactly the same, I want to do third trial. At the same time, the temperature is not the same. The colder it gets, more of the acid is going to use. So this is cold is not going to be consistent. So at least the temperature going to wait with the 2 trials. Temperature T1 or room temperature. T1 equals 22 degrees. Okay. I just want to make sure you have everything from the data sheet that you need. Okay, data that you need and what you need to do the calculation for. Okay. Concentration of the hydroxide ion, you need to do the calculation for it. So you have the molarity of HCl, you have the volume for HCl. You can set up your equation the acid-base equation of HCl plus CaOH2, balanced equation, and do the calculation and find the moles of hydroxide ion. From moles of hydroxide ion, then you find the moles of calcium ion. From, if you have both of them, you find the value for Ksp. When you have the Ksp, you can calculate delta G. And on the second page, okay, you have all the information that you need, that you couldn't be in the lab, and I performed the experiment to provide you with those information. Everything else, look at the lab manual, and because it's explained there, the method is, it's unique for this lab manual, and you should be able to follow it and do your calculation. Thank you. This is the end of experiment 8.